Hey guys, in this lesson we will understand how to make the graphs of sine ratio and its reciprocal, as well as we would also write on the properties of sine graphs and its reciprocal. To make the sine ratio graph, we would take the entire circle, that is from 0 to 2 pi. The only sine values that we would be using is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So altogether 1, 2, 3, 4, 5 points. Let's use this in the form of a table. So here we have x and here we have fx, and our fx in this particular case is going to be sine x. So when x is 0, sine 0 is 0. When x is pi by 2, sine pi by 2 is 1. When x is pi, sine pi is 0. When x is 3 pi by 2, sine 3 pi by 2 is -1, and when x is 2 pi, sine 2 pi is 0 again. We know sine represents the y values of the coordinates. So if we are at 0 mark, or if the point is here, then x is 1, y is 0. That's why we got sine 0 is 0. Here x is 0, y is 1. That's why sine pi by 2 is 1. Because this, what we are discussing, is the unit circle. Here x is -1, y is 0 again. Therefore sine pi is 0. Here x is 0, y is -1. Therefore sine 3 pi by 2 is -1. And here, when x is 2 pi, when we come back to this point, x is 1 and y is 0 again. So these are the points that we would be using to make the graph of sine ratio or of sine function. So if this is the grid, we divide the x-axis into 1, 2, 3, 4, 5 points, where the first one is 0 itself, second is pi by 2, third is pi, next is 3 pi by 2, and next is 2 pi. Y value is going to be +1 and -1, because the only y value that we have to deal with is 0, 1, 0, -1, and 0. So this is the y-axis, and we are making the graph of fx equal to sine x function. When x is 0, fx is 0. This axis is fx axis, this axis is x axis. So the first point is here. When x is pi by 2, fx is +1. When x is pi, fx is 0. When x is 3 pi by 2, fx is -1. When x is 2 pi, fx is 0 again. When we connect the points, this is how the graph looks like for a sine function. We know these functions are periodic functions, so they keep on going in a circles. That's why it's called sinusoidal or periodic function. It's assumed that you have already learned that in the previous grades, that sine and cosine functions are periodic function graphs. So if we keep on extending our x value, the graph would keep on going like this. In the same way, we can also make the graph of fx equal to cosine x for the same x value, 0, pi by 2, pi, 3 pi by 2, and 2 pi. The fx for cosine x would be different. We can put these values on the calculator to solve for cosine x as well. Now this white graph is the sine graph. Let's say we use the same grid to make its reciprocal graph, and the reciprocal of sine is cosecant graph. For making the graph of cosecant x function, we need not use the table of values. We would just use the properties of the sine graph. So if this is the sine x and this is cosecant x, we have learned in the previous units that as the reciprocal functions or rational functions, we would apply the same rules here as well, because for any reciprocal functions, the rules are going to be the same. The x-intercept in sine x graph would become vertical asymptote of cosecant x graph. So wherever we see the x-intercepts for the green graph, that will turn into vertical asymptotes. Positive and negative intervals for sine graph would remain positive and negative intervals for cosecant graph as well. Increasing interval for sine graph would become decreasing interval for cosecant graph, and decreasing interval for sine graph would become increasing interval for cosecant graph. Now we would be using these rules to complete the graph of cosecant x function. Since positive stays positive and negative stays negative for the green graph as well, so wherever the white graph is positive, or wherever the white graph is over x-axis, green graph will also be over x-axis, and wherever the white graph is under x-axis, green graph will also come under x-axis. one more thing here that is very important is the y values of sine x would get reciprocated for cosecant x. That means if y value for sine x is 1, y value for cosecant x is also 1 over 1, which is same as 1. So using all these rules, we notice that the white graph is increasing. So the green graph would be decreasing. However, it will not cross the vertical asymptote because this line is a vertical asymptote. After this point, white graph is decreasing. So the green graph will start increasing and will not cross the vertical asymptote. These two graphs will meet at point 1. That is the y value, because the reciprocal of 1 is 1. So we notice that the green graph stays positive. However, the increasing white graph becomes decreasing green graph. Decreasing white graph becomes increasing green graph. Next we have is when white is under the x-axis, green will also come under x-axis. However, decreasing white becomes increasing green. Increasing white becomes decreasing green. Similarly here, increasing white becomes decreasing green and decreasing white becomes increasing green. Here as well, decreasing white becomes increasing green and increasing white becomes decreasing green. Meeting point is 1 and -1 because reciprocal of -1 is -1 and reciprocal of +1 is +1. So cosecant x graph is represented with green color, whereas sine x graph is represented with white color. Now looking at the graphs, we can conclude important properties for sine and cosecant x function graphs. For sine x function graph, we notice that there is a max point at 1. Every time this graph is repeated, we would see a max at 1 and we would see a min at -1, and that is also being repeated. Similarly, we see that the x-intercept, also called the theta-intercepts because this x-axis represents angles, so can be represented as theta. So x-intercepts or theta-intercepts will also be repetitive in this sine x function. So if we are asked to write down the theta-intercepts or x-intercepts for sine x function, we would not be able to write down any one value because the value is repetitive. So whenever the value is repetitive, we use what is called the arithmetic function equation, and the arithmetic function equation is Tn is equal to a plus n minus 1d, where a represents the first value, n is the variable, and d is the common difference. So if you're looking for theta or x-intercepts, the first time that we notice x-intercept is at 0, so we can write down a as 0, n is a variable, common difference means after what distance do we see the x-intercept again, and that is pi distance away. So common distances or the common difference is pi. Now we just have to solve this. N times pi is n pi minus pi plus 0. So ultimately we are left with n pi minus pi is what represents the equation for theta or x-intercepts. So we cannot say that the x-intercept for sine function is 0, pi, 2 pi, then 3 pi, 4 pi, because we cannot write down all the values because these values go up to infinity. So we just say theta-intercepts is n pi minus pi, where n represents any integer. Integer is represented with z sign. So it could be minus or it could be plus because these graphs are not just extended on the positive x-axis but also are extended on the negative x-axis as well. And this is how the graph is going to look like on the negative side of the x-axis. Similarly, if you have to write down the x value of the maximas of sine x function, we notice that the maxima occurs at pi by 2, then it would occur at this point, and the x value for that is, because we are going up by pi by 2's, so this distance is pi by 2. We add 2 pi and pi by 2 to get 5 pi by 2. Therefore, the next maxima will be seen at 5 pi by 2. And after that, we would see another maxima. And this is a never-ending story, both on the left and the right side. So this is also going to be represented using arithmetic general equation. So in order to find out x values of maximas, we use Tn is equal to a plus n minus 1d formula, where a is the first time we see the maxima. We can pick any point we feel like. So we would pick pi by 2 plus n minus 1. Common distance or the common difference is the difference between the two maximas, and that is 2 pi. Now we would open this bracket. So we have 2n pi minus 2 pi. We would collect the like terms. So pi by 2 and 2 pi would get collected together. Pi by 2 is 0.5 and 2 pi is 2 pi. So 2 pi. So pi by 2 minus 2 pi plus 2n pi is what we get for the equation. When we solve this together, we would be able to get 3 by 2 pi plus 2n pi. Here also n would be any integer. This is how we get the x values of maximas of sin x function. Let's say now we have to find out x values of the minimas. We notice that the minimas for sin x function is repetitive. So we would be using the same formula. The first minima we see is at 3 pi by 2. Common difference is again 2 pi. In order to understand these maximas and minimas better, it is recommended that you watch sinusoidal functions playlist in our channel, APS Education Math and Science videos. Before watching this lesson, watching sinusoidal functions videos would help in a better understanding of all the lessons, including this one and the following lessons that we will be doing after this. So that is highly recommended to watch before proceeding towards these lessons. Coming back to the question, we multiply 2 pi with n and 1 and we get 3 pi by 2 plus 2n pi minus 2 pi. When we collect this together, we get 3 pi by 2 minus 2 pi plus 2n pi, and this would give us negative pi by 2 plus 2n pi, where n is again an integer. So we see that if we want to write on any characteristics that are repetitive, then the best way is to use this equation and sub in the values to solve for the equation to get the equation for that particular characteristic. In the same way, we can use this equation to find out the vertical asymptotes of cosecant x function. Let's say we are asked to write down vertical asymptotes for cosecant function. We know the vertical asymptotes are also repetitive. Whenever it comes to writing any repetitive values, the formula that we use is arithmetic formula, that is Tn equal to a plus n minus 1 times d. A is the first time we see the vertical asymptote. Let's say that's a 0 here. N minus 1. D is the common difference between the next and the previous vertical asymptote, and that is pi value. So this is pi. When we solve this, we get n pi minus pi, where n is any integer. And this is how we write down the vertical asymptote characteristics for cosecant x function.